Alrighty. It's Friday. And I wanted to hop on, do a couple hour stream here, and write this epoll server that I was diagramming up earlier in the week. It's been a bit of a crazy week for me. So haven't gotten around to this. And we're a bit in flux because we finished up the Linux programming interface, and I'm kind of contemplating the next learning project that I'm going to embark on. So yeah, figured implementing this epoll server would be a good small thing. It's kind of something I've been eager to implement, so be a cool little exercise. So let's go and do that. So let's go under GitHub, Cypher 0 dev. Alright, I need to think of a name for it. So epoll file server. That's pretty much what it is. Let's go in there. We can export this once we clean it up. But let's go ahead and just start on a main here. And we're going to man2 up epoll. I think the methods are epoll like wait. Yeah, so we'll have to do like epoll create, epoll wait, all that stuff. So there's epoll wait or epoll create 1. I think this is the old one because size is no longer needed, so they replaced it with 1, and then you can give it some flags like close on exec. Yeah, so we don't care about that. Let's go ahead and create our main here. I'm gonna pound include my standard lib.h, and in here we're just gonna do a stub out of like what we want to accomplish here. I'll leave the prototype here, even though we're not handling any args right now. So we need to in main thread, so we need to first open a socket and listen on port. So we need something to parse args for port. Once you have the socket and main thread, loop calling accept, and then we'll have some type of function up here, which should be a void star dispatching, or we'll say writing FDs to epoll FD, or adding. We'll say adding. I think they call it the interest list in epoll terminology. So open a socket, listening, and then we're going to need to create our epoll instance. We're going to need to spin up our thread pool. Spin up a thread pool. A thread pool of workers, reading, passing epoll FD. And then main thread, we just loop calling accept, adding the file descriptors to the epoll FD. So we need some type of pound defined up here for our pool size. I think most people call this num threads, even though it's not really accurate, but we'll call it pool size. And we'll just say 3 for now. And then we need a void star for our thread, which calls worker. It's going to receive a, if we go to man p thread create, this is going to be a void star start routine, and then okay, so we get our void star arg. Void star arg. It's gonna be a worker. Just leave it like that for now. And we need the code here to turn the arg into epoll. So we're going to call this thing an int epoll fd, is equal to a int of arg. Let me just do another thing here. It's going to need to return null since it is a void star return. And then there was some type of weird like syntax that I had. Let me see if I can pull it up. Linux program interface, ripgrep for arg. I'm just gonna ripgrep. There's a lot of args. Arg with a cast next to it. Sorry. That. Literal. So, there's a ripgrep for pthread create. So I'm gonna wait a minute. I'm not in where I need to be. Why does that not want to go? Weird. Auto jump is broken? Okay, well I guess I can't use auto jump. I did an upgrade on this machine earlier today, so I should turn some light on. Here it's kind of dark. I did an upgrade on the machine earlier today, so I guess it broke some auto jump stuff. Don't really care about that. Let's just go to source, GitHub, Cypher0, the Linux program interface. Now we can do our ripgrep. Ripgrep for, I bet you this one will show up. Yeah. So it's called int pointer t. I don't know where that type is defined at. Int ptrt. So we're gonna have to vim up this guy here. Let's see where that's at. Int pointer t is probably under standard int, I think. Int pointer t. Int ptr. That is in Unix standard.h. Okay. Let's throw that over here. Get that thing fixed. Okay. So now we have our epoll fd passed into our worker, and we'll just do a sleep or a pause. Yeah, that'd be a good thing to do, just to keep it off CPU and blocked. We can spin up our workers here. So we say for int I is equal to 0, I is less than pool size. Let me say I, plus I is the way most C programs do it, so I'll do it that way. And then here we're going to need a pthread create, so I need to declare a thread type. We ask in C, when you declare a variable inside a loop body and pass it to a is it reused for each iteration? Yeah. So if I want to create, say, 6 pthreads in a loop driven by a pound define int number. Would I want to heap allocate the pthread t on the heap? Yeah, but you need to have a separate area of memory for all. Okay, so we'll just do that. So we're going to declare our pthreads here. Pthread t array threads, and we'll say pool size. That's what I was getting at. And then here, pthread create. Create. Give it the reference to threads. So if we go to pthread create here, I don't need this thing anymore. This is gonna have some adder struct, which I don't care about. Null. I think that has, yeah. It's been a while since I use this API, but I think that's fine. The reference to worker. And, oh, interesting. And then the arg, which is the epfd. And then we want to check the return. Return 0. On error, it returns an error number that contains an error number. Okay, thanks. So we'll say int ret, and we'll say assert that, well, we'll do the nice thing. We'll say if ret is not equal to 0, then we will p-error pthread create, and we'll return exit failure. P-error is probably going to have some, we definitely need the pthread stuff, which is pthread.h. Man p-error is going to be standard IO, of course. And then the epoll FT we'll get around to adding. We're not going to need to join. Okay. Let's go and parse the arguments for the port. So in here we're going to say port, which is going to be integer, is going to be, well, first we'll say if argc is not equal to, well, I guess we can give it 2 args, so it'd be 3 total. Oops. So the first argument would be the command, the second argument would be the host port. So here we'll say print usage, and we'll give it argv sub 0, and then return exit failure. Okay, and then the port will be argv sub, we actually need to get host as well, host. We'll just ask AI to help us with this. Given a host and port, host and port as args in a C program, write the code to parse these into the values needed to connect to a socket. Here's our little fancy print usage. Should be a void print usage. Taking in the this would be a char star of command, and it's going to boop 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 boop. I don't like this fprintf, but so be it. Usage, this would be command here. There we go. Okay, it just grabs them as char stars, but then there's some type of like get adder info on host port. Okay. Well, let's go through this incrementally. So we grab the host and port as char stars. And then we have the adder info hints, and then we have adder info pointer result in RP. Socket FD initialized to -1 for funsies, and an error. I don't like forward declaring all the local variables, so I'm gonna just ignore all that. So this hints thing, families unspecified, we want TCP. Yeah, that's correct. Flags and protocol. So really what we want to do is grab this stuff. So we're going to say here, initialize the struct adder hints, and then in here we're going to give it these two things. Oops. And then this is going to be dot like that, maybe? I think there's a comma here. There you go. And then I think that's pretty self-explanatory. And then we'll need our headers. Just gonna grab everything, why not? Oops. Standard IO we already have, as long as standard lib, string, Unix standard. Okay. String.h I guess we don't need yet. Alright, so we have our hints. Hints then goes into get adder info. Ret, I'm gonna start calling this thing error. Oops, I like that. It's kind of like go. Alright, so we call our get adder info here. We'll say int error get adder info host port hints and results. What is RP? Oh, because the result is a like a pointing to an array of things, and RP is going to be our actual thing that we get. Okay. Okay. Now we have a result. Now we have to loop over it. This is going to give us back an array of sorts. And here we say RP is equal to result. If RP is not, and then we go to the next, assuming RP is not null. Oh, interesting. It's creating a socket for each one. I just want to like filter. I don't want to create a socket for each one. So how about we just use the topmost element of it? Okay, so we could use epoll to connect to each socket. Wasn't anticipating needing to do that, but I guess we could have an accept epoll, and then we could have a epoll that's used for the IO. Because there's a socket file descriptors for accepting, and there's a socket file descriptors that are the connections. So here, create epoll instance for accepting connections. Okay, so down here, man epoll create. So we're gonna do that. Say this is gonna be epoll accept FD, and it's gonna be int, and it's going to be the result of calling epoll create 1, giving it 0. And of course we'll need sys epoll, epoll yeah, we do that. Okay. Okay, we want to assert this thing, so Gaia star error. Here we'll just do a p error here of get adder info and return exit failure. And then we'll do the same check here. It's going to be epoll accept FD, epoll create 1. Okay, so in here, each one of these socket file descriptors, where is this? Up here. So socket FD is just going to be an integer. We'll call this the accept FD. Accept FD. Man to socket. And I think we have syssocket, right? Yeah. And here, I'm going to say return value. -1 is return. Okay. Okay. So we're going to continue. Can we set peer socket here? Oops. Go. And then I'm going to bring this out. I don't like it when they do the inline stuff like this. So we connect to our accept FD. Wait a minute. Is this? Yeah, it's accept FD. And we give the same. No, it's adder and adder length. Where do we give the port? This would be int error is equal to connect. Error is equal to 0. Break success. Oh, we break on the first success. Here I want to have the ability to bind to multiple accepting sockets. It's a bit of a feature creep here, but it seems like it should be something that we should be able to do. So man to connect, return value. If the connection or binding exceeds 0 return. So we say if it's not equal to 0, then we pair connect, and we continue. Here I'll say int, we'll say AFD count is equal to 0. Here, yeah, I guess we should also close the accept FD here. What happened there? Oh, I forgot that. Okay. Why is socket FD set to -1? Okay, I don't think that's necessary. All right, so we come back around. So otherwise, we need to add it to the epoll. So it's like a man to epoll create. Go down the bottom here. So there is the epoll CTL. So we want to add our file descriptor to this. So here we're going to say epoll CTL, give it the epoll accept FD. The operation is going to be epoll, epoll CTL add. Don't know why that happened, but there we go. And then the FD is going to be accept FD. And then this epoll event, I forget which this is. Oops, please go away. All right, the event argument describes the object linked to the file descriptor FD. Struct epoll event is described in epoll event type. Okay, so we want epoll in, epoll out, exceptional condition, hang up. Okay. Oh, weird. Okay. We need to look at this event. So the it says look up epoll event 3 type. Sorry, 3 type. So you got our epoll event. Events and data, user data variable. I think we have to put the file descriptor in the data. Yeah, I remember this now. You register the file descriptor, but you also have to put it in this event. So let's go and create the event. Can I do that inline? I think it gets passed in as value, right? Sorry. It is a pointer, but I think it gets copied. Let's go here. So epoll event, and we'll say event. There should be an example down here of doing that, since I asked it for it. Let's see what it's doing here. So It has a make listener. So it just pulls all that out as like a make listener function, which is kind of handy. Maybe we'll do that. So all of this. So all of this, no, it's not going to be easy to do because we have this. Okay, this is actually going to be a reference to the event. Like that. But I want to go down here. So, yeah, so they just set the adder to be any. And they convert it to the port here. Okay. Wait, why are we connecting? We need to listen. We need to listen and bind. All right, so we have our socket. It's going to be the same. Family, sock type, protocol, it's fine. Okay, everything's good there. This is now going to be, we need to do a set sock op. That's a good idea. So we use adder. And then this is going to be a, instead of a connect, it's going to be a bind. And this is going to be AFD. So we're going to bind the AFD, the adder struct. I think that's already the right type. And then size of adders, already adder length there. Change this to be bind. That doesn't go through. Then we close it. Then we also need to listen after we bind, which I'll pull this out because I like that style better. Oops. This would be error is equal to listen AFD error listen. Then this will just be a continue. Okay. So its events is going to be pull in. Oops. That's what I thought it would be. Except it would become a pull in. I don't want to use pull, I want to use epoll. Okay, so we're not going to use that because it's not using epoll. Alright, but we will use dot events is equal to, it's going to be something like this. Let's go back to this. I guess a little bit bigger. So we have events and we have data. And data is gonna be the AFD of some sort. We're gonna assign that somehow. I know the expression's not right. uint32t events And then if we go back to CTL, it should have the events here, which is epoll in, which is sys epoll. Do I have sys epoll? Yeah, epoll in, not poll in. That's why. Oops, don't have enough screen here. Epoll in. And then the data part of it is an epoll data t union. Incompatible integer to pointer conversion type. And C, how do I assign a union value? Give me 1 second. I heard some noise outside. Okay, it's a delivery outside for one of my new books. Which is a part of a set that I ordered, which is Brendan Gregg's books from Addison Wesley. Look at those big boys. So I got the system performance. I actually have the older version of this, but this one is for Linux specific. And it's hard to tell on the camera, but Systems Performance Enterprise in the Cloud 2nd edition. The first edition was Illumos or SunOS, whatever you want to call it. And then this is what just came in the mail here, which is BPF Performance Tools. Linux System and Application Observability by Brendan Gregg. So lots of performance stuff. Together, I mean, this is prolific that he has this much stuff, but together that's like about an 800-page book there. Feels like more than 800 pages. I guess maybe these are thick pages. Yeah, it feels like more than 800 pages. But I guess that's because the Linux program interface, the pages are really thin. Then this one is about 800 pages. So that's the two of these would be equivalent to, basically roughly equivalent to what I just read with the Linux programming interface. So those I'll be cracking into later. All right, let's continue reading here. And see, how do you assign a union value into a struct using the struct initialization syntax. For example, so you say dot data, and you have to say dot fd. Okay, that makes sense. I just missed the dot fd here. Okay, looks cool. And then we need to check epoll CTL. Gives back us an error. -1. So we can just say, hey, if error is equal to -1, then we have a epoll CTL bug. We're going to continue. And then if we get through the whole thing, then we'll increment our AFD count. Oops. ++. And then down here, we'll say, hey, if, actually, no, let's just print out the AFD count. Or before we do that, we'll do an if AFD count is equal to 0, or we say less than 1. Just catch the edge case there in case it goes negative. I don't know how it would, but you never know. We say if the AFD count is less than 1, then we will error out, return exit failure, and we'll just do a printf, fprintf to standard error. The value here we say AFD count. We'll say no sockets were added to the epoll. We'll just say no sockets are added, yeah. And we need a new line here. Bam. Otherwise, we'll do a printf out to. Actually, no, I like this fprintf for standard error. And we'll say, hey, we'll do AFD count is equal to %d here, new line, and we'll give it the AFD count. Cool. Did that. We now need to create a second epoll instance. So this epoll instance is going to be for the clients, the connections themselves. So this will be EPCFD, yeah, epoll client file descriptor, connection file descriptor. And then we'll need to check that one there. Cool. We might as well, we don't need it yet, so we'll create it down here. Alright, so we have our AFD count. We added our file descriptors to the epoll CTL. They're listening and bound to their ports and everything. They're nice and happy. Now we need to select on the, or we need to epoll on the accept epoll, and then well, let's do our threads here. Spin up thread pool. So we got that here. This is going to be, oh shit. I guess this would be EPCFD, yeah. That makes sense. And then I need to change this thing to be a int ptrt. And then convert that to be a void star. I think that's how you do it. Yeah. Alright. And then in the main loop, we now need to go into our loop. Give me the loop of a epoll wait. And yeah, you know what? I'll write this out myself. Let's get out of the AI stuff here. Man2 epoll wait. And there's a p wait and a wait 2. I forget the differences. So I think p wait does something with signals, right? where's the, yeah, epoll pwait, pselect. Yeah, either a file descriptor becomes ready or until a signal is caught. And I think Go does pwait timeout. It takes an argument time spec nanoseconds. So the epoll pwait 2 is like the better one if you want to do like nanoseconds. But I think what we'll do here is say forever. We're going to epoll wait on the epoll accept file descriptor, and we're going to create an array of struct epoll events, and we'll just say like 10 here. And then here, instead of just having that, we'll do a pound define. Accept epoll events size. We'll just place that in there. Why is this definition of variable with an array type needs an explicit size or initializer? It has an explicit size. Oh, I forgot to do it here. 10. My bad. All right, epoll wait fd, and then here we give it the events and the accept this guy here. Yeah. And I think there's a final argument, which is timeout, which I think I want either 0 or negative, because I don't really want to do a timeout. Says every time -1 causes it to block indefinitely. 0 causes it to return immediately. So I want -1 here. -1, yeah. So then epoll wait gives us back an error integer. And then here, if we look for return, number of file descriptors ready for the requested IO operation, or 0 if no file descriptors became ready during the requested timeout, which would never be 0. On failure, it returns -1 and sets error no. So here we say if error is equal to -1, then we're going to perr out string epoll wait, and we'll return exit failure. Okay. So we have this situation where we get back this, but this is really going to be a n here. So for int I is equal to 0, I is less than n, and then plus I. So in here, oops, I don't know what you're doing, bro. We have to handle all of the individual events. So we pull the epoll event off. If we go back to this type here, that's going to tell us the file descriptor, and it's going to tell us the event. The event can only be one thing, which is in. So all we care about is the file descriptor. So in here, we're going to say, hey, we're going to add this to the interest list. No, we're going to accept a connection. And we need to put these things into non-blocking mode. So the accept file descriptors need to be non-blocking. So when we create the socket originally, let's see, socket, we need to set sock op to make it non-blocking. Give me 1 second. Take a quick bio break. Alrighty, fix my camera here. Alright, where do we leave off here? So we had our socket that we wanted to set into non-blocking mode. So man set sock, I think it's 2, set sock opt non-block, no block, block, no. Well, if you man to socket, I don't think there's like a non-blocking mode here. Oh yeah, there's sock non-block. Type which specifies communication semantics. Okay, some sockets may be implemented using protocol. Type argument serves a second purpose. In addition to specifying socket type, it may include the bitwise OR of any of the following values. Okay. So we go here and we say, hey, bitwise OR in sock non-block. Okay. We don't care about the close down exec. Okay, so that'll make it to where the accept will be non-blocking down here. Alright, so man to accept. We give it the file descriptor from the event. So we're going to just create some memory here for the event. It's going to be struct epoll event called, we should just call it E. There's no sense in like continuing to repeat ourselves. And that's going to be assigned to events of I. I need to type struct correctly. And then here we're going to say file descriptor event or E, and then so we have our epoll event e-data fd, e.data.fd, and then I don't know what this, I'm just going to give null here because I don't care about that. a null here. And it should give me back the file descriptor, right? Turn the file descriptor, yeah. Int connection file descriptor is equal to that. And we say, hey, if CFD, we say on error -1 is return. It's equal to -1. We're gonna p error out and exit, but only under the case where it's not e again. So we say if CFD is equal to e again. See down here, yeah, e again, but e again is not defined, or e would block. We'll just continue on to the next. We'll handle it again. The rest of them we're gonna blow up. Where are these defined at? Yeah. Error now? Okay. Makes sense. Error node.h fix available. It's not used directly. What the hell? What are you talking about? Oh well. We'll leave it in. Why not? Get this thing to behave. Here we'll do that as well. So since we're doing it in both cases, we can pull it out up there. Okay, so now we accept. So we have our file descriptor. Now we need to add it to the interest list of the other file descriptor, which is the epcfd. So I'm going to just copy some of this stuff because it's going to be very similar. Down here, this is going to be CFD. CFD here as well. This is going to be epcfd event, and we'll return exit failure here. Okay. And at the end here, we'll say println, or sorry, fprintf, standard error, connection ready to handle. Let's see if we can get that far. Add a new line here. I'm sure there's some bugs that we've written already. All right. So let's cd into source, GitHub, Cipher0, epoll, Fileserver, vim makefile. Oops, go away. Vim makefile. We're gonna have an all, which is a phony. All will be main, or build main, I should say. And then build will be mkdir/p. Up here, we'll say clean as well. P build. And then clean will be rmrf. Or just say r. Build. And we'll do a negative sign in front of this so it doesn't complain. Same thing here. And then here we'll have our build/main, which has a dependency on main.c. And it's just going to gcc o build main main.c. We'll do -03 and -w all. Something like that. Make. Okay. Unused variable epfd. Epoll file descriptor. Println, or let's say printf. Standard error. Worker started on fd%d. New line. epfd. Does that make you happy? Alright. Cannot open output file build main. Oh yeah, so if you go back up here, it's also going to have dependency on build. There we go, build. And then I'd like to have when it's done listening, I would like for it to here print out fprint, or this should be like printf. Fprintf, fine, whatever. Standard error on. This is going to be RP. AI adder. And in here, what is this thing? Socket address for socket. AI family, socket type, protocol, that's fine. Adder. I need a way of getting to this structure. AI adder. Sorry. How do I convert and what is this thing called? Where is it? Up here? Yeah. AI adder struct sock adder pointer to a printable. How do I printf out and there, just do that. Bam. You do the inverse. You do get name info. It gives it back RC, and it'll write in to host and serve. Okay. Oops. So we say listening on space. We might just hoist that up into there. Okay. All right, make. Okay, let's do a build main. It's going to complain, so we say host is going to be localhost. Complain and still 1 2 3 4 5. Bam, invalid argument. Okay, so that was from epoll create one. Epoll create one. Invalid argument. How is that invalid? Okay, we'll do epoll create then. And then this has to be like a non-zero value. I remember reading the docs on that. Epoll create. Make. Still invalid argument. Oh. Let's go back to this. GCC build with debug flags, no optimizations. So Vim, or say foreground here, I think, yeah. Take away the O3. G, we'll do O0. O0. G. Okay. Oh, is this W extra? W extra pedantic. Okay. Make. GDB build main. Continue. Restart. Continue. Restart. Okay, it just exited. So I need to set some breakpoints here. Can I set break on line main.c line what? What, 55? Continue. Restart. Oh, that breakpoint did not work. How about we just set it main? Breakpoint main. Restart. There we go. Help. Step. How do I do a single step? Help. Breakpoints, internals, maintenance commands. Running the program. Advance, continue the program up to the given location. Attach, continue, detach, disconnect, handle, yeah. Jump. Next step program proceeding through subroutine calls. So next will proceed through subroutine calls. Step program until it reaches a different source line. So it would be S or N. Okay. Next. Why I'm in print? Oh, because okay. Args localhost 12345. Is that how you do it? Help args. Help. Running. Help. Well, I think, yes, please quit. I think I can do like localhost 12345 here, right? And do like the dash thing here. Say pargc, prv, and if I say at 1, gdb set args, okay, so you dash args and just give it the whole thing. Okay, that makes sense. Okay, let's quit out of this. We can say args. There we go. Restart. Breakpoint main. So now it's getting to the epoll create failure. Restart. Next. So if I print out host, print out port, print out hints. Hints was something that I gave it. And I just said the socket type and the protocol could be any. Alright, and then print result. Okay. Next. Flag 0. Next. Okay. Maybe it's that not equal epoll AFD. Print epoll AFD is 3. Oh, that's the actual FD. That's the error handling here is wrong. Quit, please. Yes. Man2 epoll create. And here on success, on error, negative return. So it's not equal to -1. That's what I need to do here. Oops, not there. Sorry. Needs to be not equal to -1. And then if we go to the next one, same thing here. -1. Great. Let's quit that. Make. And we'll just run build. Oops. Build. Come on. What the hell is going on here? There we go. Alright. It's, oh, did I not run make? I thought I ran make. Oh, it's equal to -1, not equal, okay. I'll get it right one of these days. It's equal to -1. There we go. Make please. Okay, so it started up 3 workers. It has 2 connections because IPv6 and IPv4. And then I'm going to do a little split here and say, hey, netcat connect to localhost 1, 2, 3, 4, 5. And it says it's ready to handle. So everything appears to be working, aside from that silly glitch that had in the error handling. So now we're up here where we're just pausing. So what we need the workers to do is to do their own waiting. And I'm going to kill this thing. So we got into the point where at the accept thread adds socket FD to the interest list in read-only mode and non-blocking mode. Yep, exactly. All right. And they add them all to the interest list, right? Yep. Gets added. And epoll CFD, I assume is going to be a non-blocking mode. If not, we could force it to be in non-blocking mode by using set sock opt. Pretty sure we can do that. But if I look at where it's defined at, sorry, not that one, this one's CFD. The accept, the file descriptor accepting on is in non-blocking mode, so I'm pretty sure it's in non-blocking mode. How do I tell if a socket FD is in non-blocking mode or not? FCNTL. To read, it's non-blocking. Okay. We'll just throw this up here. Why not? Just throw it up here. Come on. We'll do it up here. I think FCNTL is like more up there. All right. What is this thing freaking out about? Use of undeclared identifier E? Was that because this thing got added somehow? I think that makes more sense, yeah. Okay. So if flags equal to -1, we say, hey, -1. If flags has the non-blocking, if that is not equal to 0, so yeah, okay. Okay. Make build localhost Oh, this is after the epoll has the event. So okay, it's not blocking. And then down here, after we accept, we're going to say e.data.fd socket is non-blocking. e.data.fd socket is blocking. And then we'll do the same thing down here after we handle the errors with CFD. We'll say, hey, oops, CFD, okay. Make, run over here, and we're gonna say, hey, you're going to netcat localhost. CFD socket is blocking. So we need to use fcntl to set the socket to non-blocking mode. So in here, we did say, hey, if we go into this, fcntl is non-blocking thing. If we pull that out here, we say, hey, CFD, we're actually going to set. We're going to need a get, and then we're going to need a set. I think it's the way this thing works. So we get the flags from that. We'll call these C flags. And then if it's -1, then we're going to have to P error out. P error. And we just say fcntl return exit failure. And then we're going to add the non-blocking flag in. Oops. So you say C flags. I think it's going to be an or equal, but it might be an and. I don't know. Usually they're or. And then here we have to repeat this, but we're going to say set FL. And in that case, we're going to have to pass in the C flags. And this goes back a error. Man fcntl. That's the 3. Isn't there a 2 version of this? Yeah. There's no example code. Is there blocking? Nothing about blocking. Let's go here. Block. This is the O non-block. Okay, we'll just grab this instead of mucking with it. But you do have to do a get and a set. And it is nor equals. I just didn't want to have to read all the... I pretty much wrote that whole thing there, but this is a better solution. Oops. If I can copy it. So I'm going to pull all this stuff out here. And we're just going to say set, we'll do this guy here. Here we go. Int error is equal to that. If error is not equal to 0, then we're going to p error. And then we'll delete all this stuff here, these switches, once we're done testing it. Alright, so make, and then we run, and then we connect. Yep, everything is now blocking. Cool. Alright, so let's delete these switches. We don't need this is non-blocking thing anymore either. Oops. Alrighty. Cool. So we've gotten to this point where we have our epoll file descriptor ready. So these guys need to do their own little loop. Similar to this, but different. So I'll go ahead and say copy this and go up to here. Oops, go away please. And instead of pausing, we'll do that. And then instead of epoll event size, we're going to say IO, epoll event size. So be IO, EP, this would be, we call it EPFD at this point, EPFD. Okay, so we're going to wait, handle the events. The events, we're then going to, not going to accept. We don't need to do any of this stuff. And we don't need that either. Here we'll say fprintf to standard error working on fd %d. And then we give it the events.data.fd. Just to show that we can get read operations here. And then the other thing we want to print out is the event type. fd type %d here. It's going to be e.data, not e.event. I think that's what it's called. If we look at E is a epoll event. Events. Sorry, and it's a uint32. Events, yep. So let's go back here and kill that. Make, oops. We gotta fix that. Yep. So here we're just going to say, hey, we're gonna p error and continue. I think that's all we need to do there. Bam. It's firing because we're not performing the reads. Okay, so now we're in the waiting for epoll events. Our worker thread's picking it up. It's working on it. So now we need to do a read and then write. And I think I'll get this to the point where it's doing an echo server, a basic echo server. And then I'll call it a night because I don't want to do too much work on the HP side of things. Why is the Kava thing still popping up on the live stream? It's no bueno. No bueno. And I got a spammer to block here. Bye, Felicia. All right. So let's get to the point where we're echoing out, and we'll see how we feel. Okay, so based on the event type, we should perform either a read or a write. We're not going to do both. So here we go. Each worker should have just an array that I can read into. So this is going to be a character buff array, and we'll just make this 2048. It's just for testing. It's not really like anything important. And then here, because these bytes are new line terminated, all the reads, and they're not null terminated, that means that we're going to have to keep that in mind, because this is a bunch of random garbage here, potentially. Okay, so let's go ahead and say if e.events ampersand, what are the event types? So this is be epoll CTL, I think. Man to epoll CTL events. Epoll n, here we go. If epoll n, then we will fprintf performing read new line and that and go over here, standard error. Okay, and then otherwise if it's out, performing write. The problem is that these file descriptors, so the workers themselves cannot contain the state, because you could perform a read and then it not be ready for writing, and then you gotta like put it back on the epoll CTL. You gotta add it back. Yeah, so this needs to be, this can't be just like a thread local thing. This would work, and we could heap allocate it. Okay. So it's performing its read. I just want to test that branch worked. That's what these are for. Oh, okay. What I don't like this. The color is red. It makes it seem like there's an error there. Okay, so this needs to be like a struct. We'll call this a struct echo record. And then we actually define the struct. Struct echo record is basically we need n, which is bytes, the amount of bytes. Sorry, int n. And then we also need the actual char star, which I guess will be heap allocated. Call this buffs. I think I need a semicolon here. Is that how you do the whole thing? Over here. Yeah, exactly. Okay. So this is a huge assumption. We'll say to do a huge assumption that reads are atomic. Is there fix me? Fix me? Oops. It's red though. Okay, so we perform our read into I guess down here we need to initialize the element. So we have everything. We have the boxes for these structs kind of put into memory here, but they could have garbage data for n and for char star. So what I'm going to do is when I add the file descriptor to the this CFFD here, when I add it there here, which means that the connection ready to handle should be up here, right? Yeah. I don't know how that got down there. All right, in here we're gonna say buffs. Sorry, buffs with one F. Sub CFD. And to do, I'm just gonna do like 4096 here. This needs to be sized based on ulimit. So down here, oops, this thing got messed up. So buffs CFD dot n is equal to 0. And actually, before we add it to the thing here, we should zero it out. And then here we're going to say buff itself is going to be equal to malloc of, I don't know, we'll do 4096. Okay. All right, and we just assume this is, we have to cast this to char star, first of all, and then we need to check to see if it's null, because this thing can give you back null and error. Function return a pointer to allocate memory, which is suitable to align for any type of, okay. On error, these functions return null and set error. No. Okay. So what we need to do is say, hey, malloc, this will be a void star, buff is equal to that if, and here we say if buff is equal to null, then we need to blow up. This really is a blow up moment. So return exit failure, and we'll p error on malloc. And then here we cast the buff to a char star when we assign it to the structure. Okay, and then I need a semicolon here. And then I'm gonna pull this end down just to make it kind of like nice looking. Let's keep all that in the same location. Okay. All right. So now we have our memory allocated that we can read into. So we're gonna say read into buffs of our e.data.fd dot buff, and we're gonna have to pull this thing out because the buffer size max, I would say buff size here. There we go. So we're gonna need it down here because man to read. Read our e.data.fd into buffs e.data.fd.buff, and this will be count of max, or sorry, buff size. This gives us back n, which is an integer, and we say, hey, we can assign that directly into the buffs of e.data.fd.n. Actually, no, we're going to perform the read and then check for errors before we assign our n here. Int n is less than 0. Oops, sorry. 0. Then we peer out read and exit error failure. Okay. So that performs our read. To do oh, we might actually need to do the exclusive access thing. I didn't even think about that. pthread self. So in here, we're going to say this guy %d. Oops. pthread self. This thing returns a pthread t, which is just an integer type. I'm just going to comment all this out for now to make sure that this thing actually works. Clang format specific int, so I need to do a long, I guess. There we go. Alright. Make, run, and then connection ready to handle. See, this is where we're not getting exclusive access. And that's simple enough to fix. So we need a mutex. So we'll just call this mu, which is a, pthread mutex t, I think. And then in here, if we look for man pthread mutex wait or lock, there we go. So we're going to do a try lock. So we're going to try to acquire the lock. If we can't, we just continue in the loop. Someone else grabbed it. So what we're trying to demonstrate here is that we can get exclusive access. So I'm just going to pause here once I get working on something. And then I'm going to add this back over to here as well. Oops. Which will be pthread self. Okay. So here is where we're going to do a try. So we get the event, but we could get it on multiple threads. So we're going to try to acquire the mutex. So we say buffs, not a great name now that has a mutex, but whatever. I guess it's fine. Buffs cfd, sorry, e.data.fd .mu. So this is going to be the mutex itself. So we're going to say pthread mutex. Oh, we need to initialize these mutex as well. So down here, let's get that initialized. So buffs cfd.mu is equal to pthread. Sorry. No, we just do it like this. Pthread mutex init. Give it the pointer to this location, and I don't want to initialize it to any special value. And then we should test the error. We'll say int, and then here say init return, always return 0 in success. If it always returns 0, I'm not checking it. Sorry, brother. I don't know why you have an integer. What is this thing? Can I just give it null? Initialize the mutex object is pointed to a mutex according to the mutex attributes you specify in mutex adder. If mutex adder is null, default attributes are used instead. Okay, great. You're getting a null. Okay. So then up here in a try lock, yeah, here. What am I doing? A try lock of that location, and that's all we need to do. And we'll look for try lock docs. Behaves identically to lock, except that it does not block the calling thread if the mutex is already locked by another thread. We're calling thread in case of a fast mutex. Instead, returns immediately with the error code ebusy. Okay. Ebusy. So int error here, and we say if error is not equal to 0, because that's what we saw down the return values. Other mutex function returns 0 in success. So not 0 would be a failure. So here we say if error is equal to ebusy, then we're just going to continue because someone else grabbed it and we're not prepared to do the IO operation. Otherwise, we'll p error out from pthread mutex try lock, and we'll exit with exit failure. Okay, cool. All right, so we attempt our try lock. The other thing we need to do is release at the end. So this thing's gonna deadlock because he's just gonna pause. But I think what I'll do is I'll just sleep here for, we'll say 2 seconds, just to slow it down. And then we need to release down here. So if we go back up here, there's some unlock, yeah. So we'll just do something very similar to this. Here, instead of try lock, we're going to say unlock. So we acquired the lock here. Once we got past here, we have the lock acquired. This, because we got the error code, we can assume that the lock was not acquired. We don't need to release it. Doing some IO with the lock acquired, usually not great. Sleeping's not great either, but it's fine for testing. None of this is really important right now. pthread mutex unlock, then we give it that. It gives us back an error that we can then check, and then I think the return values for this unlock function returns the following error code on error, invalid, or perm. Both of these I should just blow up. So I'm going to take out the busy case and just blow up with a unlock. Unlock. Okay. And then it's ready for the next thread to pick up. Okay. Make, build, run. So now we got our thread IDs on our workers. I'm going to try connecting now instead of localhost. If I cat out etc hosts and grep for localhost. So I'm going to try this syntax. NC to the IPv6, 12345. Just for fun. So it's connection ready to handle. And then I'm going to do some IO operations here. So I'm going to say hello world. And now only that guy. Every 2 seconds it can flip to another one. But now we have exclusive access, which is great. Okay. Now we can actually do our IO instead of goofing around here. So perform our read. So what I'm thinking about here is like we perform our read and then ideally we perform our write immediately after the read. But since we're in non-blocking mode, what if read fails? With E again. E would block. Okay. I'm making a lot of assumptions here just to kind of get something running up and running. So let's just do our write. So our write's going to be pretty much identical, but in this case, write e data fd. Instead of buff size, it's going to be buffs of e data dot n. No, not e data. Buffs of e data fd dot n. So we pass in our buffer, our n, and we write to our file descriptor. Let me get back n here. If n is that, then hey, what if it failed because it was blocking? All right. Well, this should function, but it's like not exactly what I want to do long term here. Let's connect again. Hello. World. Test. Foo. Bar. Can someone else handle me? It looks like it maintains exclusive access, which isn't what I would have thought. I would have thought it would rotate. Because all the threads right now should be waiting on epoll. Well, let's do another one here. We'll do netcat : 1 1 2 3 4 5. Hello. So now it's going over to 64, 60. Oh, I got EOF. So now we're saying, okay, type 1. I think when read hits 0, we need to just remove it from the list. Yeah. So we perform our read. If we get back, if n is equal to 0, then we remove the file descriptor from epfd. So this would be epoll epfd operation. I gotta look this up. Man to epoll ctl. So it's gonna be epoll ctl. Oops. Del. And then the fd will be the cfd or e.data.fd. And I think I can just do null here. Doesn't make sense to do anything other than null there. All right, and then this can of course error. And then here, let's look for ret. -1, so we just need to test for -1. Just grab that from the over here. If error is equal to -1, then we p-error and we exit failure. Okay. Quit. Make. Run. NC. Hello. Okay. And then we do Control D. I feel like I should have something here that says like removing printf, fprintf to standard error, removing fd, %d, new line, give it the fd, which is e.data.fd. There we go. So now make, and over here. Okay, and then we can go Control C, moving FT12. Cool. I mean, it seems to be working. How about we do this, say like while true, echo hello, and sorry, while true do echo hello sleep 0.1 done into that. And then we can do this in like a couple different terminals here. So we have some currency. Read resource temporary unavailable. Interesting. Read. Yeah, so that's exactly this condition here. Where he tried to perform the read was blocking. That's funny that under 2 concurrent it's because the read end basically we got a epoll event that said, hey, this thing's ready to read, but it actually the read had already completed. So it was a spurious triggering of the event, which we just have to assume happens. Like when epoll says, hey, your file descriptor is ready, there's no guarantee that it's ready. Like it's almost like it's saying like, hey, I'm pretty sure that your file descriptor is ready to be read from. That's like what it's telling you. And so we got a spurious event there where the read happened, and I did an exit failure in this situation, but I did note as a to-do that this thing can totally fail with E again, in which case we need to, handle that. Which probably, to be honest, is just a continue if you're in the read stage. But it could be like a partial read where like no, it can't be a partial read if you have E again. But we can have partial reads. Which is this other thing, this huge assumption that reads are atomic. I need to put here, what about partial reads? So yeah, I mean, there's a lot that needs to be worked on here, but the overall kind of like idea, I feel like I have fleshed out. So next steps are to handle all these cases of like partial reads and different error codes that can return, and then allowing for separate reads and writes. So if the read is a full read, not a partial read, it's a full read. Which what does that even mean in the context of like a streaming socket? Like I'm using this idea of like new line delimited as a full read, and in the HP context, a full read would be the entire header for the file that's being requested. But there is no real like concept of a partial read. Everything's could be a partial read conceivably. So in the HTTP context, we need to read until the header condition is completed, which is like I think 2/r/ends in series in sequence. So we have a very definitive ending byte sequence for like the headers, the HTTP headers being sent. In the context of just an echo server, it's a new line. So we have very definitive conditions for when we say the read is complete. So in that context, we could have a partial read where we read like 3 bytes and the actual message, the new line delimited message was like 12 bytes, just as an example. So we can have partial reads, but only because we're we're imposing a semantics onto the streaming API. The streaming API itself does not really have a concept of a partial read. It's just giving you the bytes as they come in, So that's one thing that we have to like consider is like the conditions for us to say like the read phase has completed. And then the transition to the write phase, the read phase could be completed in multiple reads, by the way. It could be like n number of reads to complete the read phase. Once that's completed, it has to transition to the write phase. The first thing it's going to do is attempt to write on the entire buffer. And that write may just immediately say, hey, I'm blocked. Go, do something else. And so we have to handle that condition. And then retrying that write. So we need to have like some type of like offset. That's what I had in here, a read index. The write index for the HTTP file server will be the file descriptor for the file, basically. Like this file descriptor will point to a file description that has a seek offset. So we don't have to track that ourselves. But in the echo server, we'll have to have a read index and a write index to kind of keep track of those things. So transitioning into the write phase, writing everything out, making sure that the file descriptor gets placed back into the epoll interest list in a way that it will then be picked back up for writes only and not reads. Because like we're switching from like read mode to write mode to read mode to write mode. We're not concurrently doing reads and writes because the read has to be completed for the buffer to be in a state where you can write it out, and then the write has to be completed for the buffer to be a state for us to then reuse the buffer for the next read. So there is no ability for us to do with this echo server concurrent read and writes on the same file descriptor, if that makes sense. All right, well, I'm going to leave it there for tonight, and I'll be on tomorrow to work on this some more.